So this talk will be about open science, and it's increasing the impact of your research through open science. Okay, this is Joaquin Torress. I introduced myself before. I'm working at the University of Valencia as a senior researcher. And if you need my contact details, here's the QR code. I will share the QR code also later. So here I am. Just to put a bit perspective of my background, I did my PhD in computer science and neural networks 20 years ago. I started 20 years ago. So I was working on the neural networks research team for 10 years. And then I moved to the robotics one, where I was around 1 year. And then I joined a new research team that was aimed to provide an indoor location solution for smartphones. I was there for 1 year, but I ended up being there for almost 10 years. Then I moved to the spin-off company Ubic, where I was around 2 years. And then I joined the University of Minho in Portugal because I got a Marie Curie grant. After that, I got the position as senior researcher in the University of Valencia. So here I had an animation with the different pictures of myself from 10 years ago to now, just to show you that research makes you to become older and older. So the presentation will be divided in 3 parts: open science, and then one about use case on a conference reproducibility, and one of them about the impact of a data set. So there are a lot of initiatives for providing open science. We have DORA, QARA, the Hong Kong principles. And there is a lot of interest by the institutions to have this open access communication of our work, because they are paying us to do research, but then we have to transmit it to the society. For the Hong Kong principles, there is a list at different stages of your research, from the study formulation to the report and publication to the dissemination. It's not public dissemination is not just publishing a paper. It's publishing a paper and then communicating to the audience, like we are doing now here. So you have the relevance of those items and some indicators of how to do this kind of open science at the different stages. Also, the funding agencies are working hard to, let's say, encourage the researchers to provide their results in open science. In some of programs, it's almost compulsory to provide your research in open repositories or in an open access format. You have from Europe, from UK, also from Swiss, different funding agencies encouraging or giving mandatory to publish in open science. But releasing a data set is not just to plug the data set somewhere in your website and that's it. We need to comply with the FAIR principles. The first one is that it must be findable, right? If you put your data set in one place and you don't communicate, here we have our data set, it's there, but no one can reach it. Then it must be accessible. Accessible in a way that it can be easy to reach it. Generally, in the publication, you have the DOI, which is a unique identifier for all research works on data sets, papers, and so on. If you provide a large URL with some strange symbols and so on, it's very difficult to type it on your browser and to get access to the data set. So usually there are repositories that as the University of California Irvine or the Zenodo repositories that provide URL with every entry. Then it must be interoperable. If you provide the data set in a proprietary format that only you have access to, okay, the data set is there, but no one can use it. So it must be interoperable, able to work with your computer in MATLAB or with the computer of someone else with Python or whatever. And finally, it must be reusable. So I generate my data set for my research. I put to the community. So if it is relevant, you can use it, or you can use it, or she can use it. If it is not reusable, you cannot reuse in other algorithms or for other works, then it's not complying those principles. The problem that what we can find is that the culture is our strategy for breakfast. You know, we have the strategy for having open science, but we have a momentum. In the last 2 decades or 3 decades, it was just published. No matter of open science. So it was publish. That was the indicator, publishing. The impact was not an indicator of quality of research. So we had, in the past, quantity over quality. Now we are shifting to quality over quantity. Sometimes it's better to have 2 good papers with impact than having 20 papers. Because you can have 20 papers that are there published, but no one is caring about them. Maybe you have 1, 2, 3 papers that are top, and they get citations. They get people contact you for collaborations. People contact you for project proposals. So sometimes we have to change our mind and go for quality and not select quantity. The issues that that cultural heritage has is that the quality of the scientific progress has decreased. There are some publications in the literature that are incremental. So you see an award a year after, and the improvement have been minimal. Then the time and money are wasted. We got funds for research. If we are reinventing the wheel constantly, that money is lost. Finally, the public is losing the trust on scientific findings on scientific works. I have found works where, after reading them, I said, okay, that paper should have not been published. Why it has been published? So to put in context, some journals have now 10 more publications published than 3, 4, 5 years ago. This is not sustainable. And also the people that is working in research got frustrated because they see other papers that are not that relevant that are getting published. So my motivation, just to explain a bit this, is explained by Ruby. Ruby found an analysis that there was a correlation between 2 variables. She did an experiment and she found variable A and variable B are correlated. Good for her. So it's very important for her research field. But she must ensure that the work is repeatable. She can repeat the experiment in the same conditions and get the same results. With machine learning, sometimes you repeat the experiment and you get different results because there are random seeds, there are random initialization there, and it's not repeatable. In those cases, what is usually done is when you report the results, you don't report the results in 1 run. You report the results in multiple runs, and above that, you provide the seeds you use in your experiments so that it can be repeated. So same researcher, same code, same data, same results, repeatable. Then we have replicability. Imagine that Ruby has Avi as associate researcher in the lab, and she asks him to take her code and her data and reproduce the results independently. If Avi is able to get the same results, then it is replicable. If not, it's not replicable. If with the same data and the same code, you get different results in a different computer, it's because something is failing. Maybe the version of Python, maybe the version of whatever, or maybe there were some issues with the code that were not identified. And finally, we have replicability. Replicability is a bit different with respect to reproducible. Replicability is like when Ruby sends to Avi just the code, but not the data. Imagine that you do an experiment here and you want to replicate in another place, just to confirm that the 2 variables were related or not. That is replicability. If with the same code, but different data, you are getting the same results, it can be replicated. Because in many cases, when you are using different data sets, you get different results. So those are the 3 principles of reproducibility. It must be repeatable, replicable, and reproducible. Okay? Just to put an example, with reproducibility, the environment is a key factor. If you collect some measurements here, they will be different than if you collect later when the environment is crowded. If it is empty, the signals behave in a way. If the environment is crowded, they behave in a different way. With the data, if you publish the data in strange formats, the way to get to the audience will be much lower. Sometimes CSV files are the best option. The same for the code. If it is unintelligible, you cannot do anything. Also, when you provide the code, you need to provide the libraries you use. It's different to run the experiments in Python 2.8 than in 3.1. I faced that problem. One of the versions had a bug. So I was running my code and it was working on my computer, but it was not working on the computer of my colleague. Then you have to document everything. This is important. You have to document everything because when you want to write the article, you spend 90% of your time doing hard work and just 10% of the time for the results. But when you write the paper, you spend 90% about writing results and only 10% about the procedure to get them. It's important to know how you reach the result. It's important to know how you reach a particular neural network configuration for a problem. And just to finish, if we are not having environment, control, data, quality, code quality, and documentation, finally, we are reinventing the wheel. So I arrive, I have an idea, I prepare experiments, I get the results, I publish. But when someone now new enters, they don't take care of what I did in the past. So they do the same. And we are constantly doing the same in some cases. So we need to take care of this, is to do a good literature survey, and then when we document, to document everything perfectly. I will pass over this case, so I will shorten my presentation, and then open science in conferences. Me with some colleagues, we did analysis of what was the status of open science in a conference. We characterized the open research data, the open code, and the open materials, just to have a snapshot of the state of the conference. I said 6 researchers, and we did the analysis in pairs. So we cross-checked everything twice to be sure that what we were providing was right. And the first one was that in that conference, still based on data, because at the end we need data to do our experiments, around 1% of papers were not dealing with data, but around 20%, 25% were dealing with a strong component of simulated data. There was no real measurements, and they were based experiments on data generated synthetically, which is kind of weird because we are working on location. So why to simulate? Sometimes we don't have access to the technologies or we don't have access to the facilities. And here, because of the conversion of the PDF, you cannot see it, but the key is that only around 25% of papers are dealing with open data sets or open materials, but only a very few, between 5 to 6%, are providing new materials. So even though we are a community that is working on open science, still we are far from having a full open science conference. Regarding the technologies, most of them are about Wi-Fi or Bluetooth because the measurements can be taken easily. The words dealing with advanced technologies are usually often not providing the data or the data sets. Finally, as I said, it's Wi-Fi and Bluetooth the most interesting ones. And also the experiments are usually done in small areas. Sometimes they take the facilities, the laboratory, or the corridors around the laboratory to perform the experiments. Sometimes we need to move to larger areas. We need to do a factory deployment to test that the system is working in real conditions. So that is like office. And most of the works are dealing with machine learning, right? But the bad practice of machine learning is that you have the training, the validation, and the test sets separately because they must be independent. But what we found is that some researchers are taking all the sets they are joining and they are applying random split. They said, okay, this is what is done usually in the literature. But this is against open science because if the training, validation, and test data are provided as a single package, you must use them. You cannot play with data to get better results because otherwise you can have data leakage. Because if the data you collected, the measurements are dependent, and you applied this random split strategy, what you will end up is to have the same data in training and in testing, so your system will be perfect. It was for the case I wanted to show you before. They were claiming with a technology that is usually providing 3, 4, 5, 6 meters of error indoors, they were claiming 0 centimeters. That's impossible. And finally, we'll explain the impact of a data set, because it's now 10 years ago, we published a data set for Wi-Fi fingerprinting. It was collected in 3 buildings in our campus. There were 3, 4 floors each one, and we collected around 25,000 samples, 25,000 fingerprints. We involved 50 people and 30 different devices to collect data, different smartphones, and we published the data description in a conference. So that paper has now more than 600 citations. It's the most cited paper in that conference. So we took all the papers citing that data set, we restricted to the 10 years from publication, and we used Google Scholar and Scopus to do that study. And we used the Prisma methodology to do the systematic review. And what we found is that the number of citations is growing. This paper was taken end of 2024. Now the values for 2024 are higher. It seems that after 2020, after the pandemic, the interest on the dataset grew because we had a pandemic, no one could work on the laboratory, so they moved to the open datasets to do research. And it's a trend that we are having now. And now it's constant, it's around 90 or 100 citations per year for the dataset. But having 100 citations doesn't mean that the dataset is being used. So we analyzed the 600 papers, and we discovered that only 284, about the 50%, they are using the experiments in the papers. The others are citing the dataset because there were other, let's say, conclusions, or there were other messages transmitted in the paper. But still, 300 papers are using the dataset in their experiments. I took the top 6 most cited, which is around the 5%. Let's say around the 1% of papers cited in the dataset. And they are also highly cited because the topic was interesting. The paper they did was wonderful. And some of them are around 400, 200, several citations. There are papers that are impacting. Some of them are using only the dataset I provided, others are using also additional ones. But the message is, I published a dataset, I got credit, but I allowed at least 4 research teams to have top papers. This is the impact. It's the direct impact on me, but the direct impact on the community. So sometimes when you are having a data set, you have to think it well. It's good for the community, publish it, because it can have benefits for you, but also for the community. Also in the conference, we analyzed the papers using open materials and the data set, and we saw the same thing that there were marginal. Less than 5% of papers were using open data. But that changed in 2018, the conference in Pisa, in NAT, and then a year after in Pisa, where we reached almost 15%. Then we had COVID. And after that, we are always over 20% of papers using open data sets. I think that this is a good sign because it's a good sign because we are moving to open science to have papers that are using open data sets and that can be the process. Finally, a big picture of the papers published within that conference. Just to show that the most cited paper ever in the conference has been that data set. It's not a paper about a method, it's a paper about the data. But this is important because that was not the first paper published in the first data set published in the conference. And that moved to the reasons we think that paper has been cited. First, we didn't restrict the experiments to a small area. Location. We need to cover a huge area. Then we perform a massive collection of data for training, validation, and testing. Then we applied, or we considered the user and device diversity. We collected data with different smartphones, different people, males, females, young, adults, just to have heterogeneous data within the data set. As said, it covered 3 buildings for estimating the latitude and longitude, regression problems, but also the classification for road identification and building identification. And probably this is one of the most important parts. We invested time in communications. We went to the conference to communicate that we had a data set that was useful for the community. We went to seminars. We went to PhD schools. We went to the social media. It's not just to publish the data set. Here is the data set and you forget it. It's that you have to invest time in communicating the data set is there. Also, we hosted international competitions with prizes. So people start to say, okay, there is a competition, there is that data set, so we are going to start to work on that. And also we hosted it in a well-known repository for machine learning, the UCI, University of California repository. Now you have also alternatives like the European Zenodo that provides a DOI and a large space to publish your data sets and provides a DOI, which is important. It's permanent, it's persistent. The data set will be there for years and years. It's not like when you publish in your website that maybe in 1 year, the university will change your URL and the data will not be available anymore. It happened. People publishing in Google Drive, links broken, Dropbox, links broken, GitHub, with the repository has disappeared. And finally, because we provide as plain CSV files, simple. And finally, because yesterday there was a message from Manil saying ChatGPT. It's not just ChatGPT, the problem. You need to consider that when we provide reproducibility, it's because we want to allow people to make a significant contribution after that. There are some concerns not only about ChatGPT, there are some concerns about the optimization problems, like metaphors based on animals. I recommend you the reading of those works because this is becoming a huge problem in the community because you can apply one algorithm today, one algorithm the day after, another the day after, another day after on the same data set and just getting incremental improvements over the previous ones. So this work has been taken funded by those institutions. I will ask Valeria to take a picture because they asked me to have pictures saying that we got funded. Sorry for this. And I thought I wrote it well. Dan Javadalu, it's okay. Thank you.